Good afternoon, ladies and gentlemen. Welcome back to the third installment of finding areas of two-dimensional shapes. So far we've looked at finding areas of squares, rectangles, other four-dimensional or four-sided shapes. We've also looked at triangles, and then last time we went ahead and looked at regular polygons, circles, etc. Right now we're going to jump into composite figures. Composite, plain and simply, is adding a bunch of figures together into one conglomeration. I'll show you what I mean here. In these figures are not normal figures. In fact, this first one, it looks like it's a trapezoid with a circle on top of it. Composite figures are very easy to find the areas of. All you need to do is break it down into a few pieces, and you can find the area of each one. I encourage you to pause the video now and try to find the areas of each of these before I show the answers in just a moment. For this first one, we need to find the area of each of these missing shape, or each of these individual shapes. First one is a trapezoid. Remember our trapezoid equation. Area is equal to base 1 plus base 2 all over 2. And we're going to multiply that by a height. So we can go and write that out as area is equal to 20 plus a 32 all over a 2. And we're going to be multiplying that number by 14. Please, 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 as you're putting these in a calculator, put these two in parentheses. 20 plus 32 should happen first to make a 52. Divide that by 2, and then multiply that by a 14. You're going to get an area of 364. 364 for this top area. Now for this other portion, this circle, it's a half circle. Your inclination is correct. I'm going to draw this in red now. To find the area, we just need to find the area and cut it in half, really. If we do 1/2 pi times r squared for this one, that's going to work just fine. What's our radius? Well, our diameter is 20. All the way across is 20. Diameter is just going to be 10, or radius is just going to be 10, half of that. So we can go and type that in. Area is equal to 0.5 times pi times 10 squared. Typing that into your calculator, 0.5 times pi times a 10 squared, which is 100. That's going to be 157 point. Yeah, let's ignore the decimals. 0.08. Let's ignore the decimals. About 157. All right. 157. As our last step for this first one, we need to add these two together, 157 plus the 364. That's going to give us a grand total of 521 millimeters squared. We went and broke this down into pieces, into the trapezoid piece, into the half circle piece, and we went and solved. For this next one up here, we have several different pieces. I'm going to try to break it down into as few pieces as you can. I noticed that we have 3 triangles and a trapezoid. Yuck, I don't want to have to deal with that. Instead, I'd like to deal with some nice pieces like, let's go and highlight this in orange. This parallelogram looks very nice. The height's 5. The base is 8. 5 times 8, maybe 40. We'd say that the area on top is 40. For this other one, we have a triangle, height of 5, base of 10. I'm going to go ahead and highlight this in blue, just so it's a little different. Area is equal to 1/2, so 0.5 times our height times our base, or base times height. You can write that in whatever order. I know 5 times 10 is 50, half of that's 25, so our area is equal to 25. Area of this triangle on the bottom, 25. Composite area of this whole thing, we want the whole composite area. We can go ahead and add up 40 plus 25, that's going to give us a 65 units. That's going to be in feet squared. So we're going to say that this composite figure has an area of 65 feet squared. To be honest, that's all you've really got to do here. There's example 1 and example 2. You're done with those. With this one, I'm going to let you work on this one on your own. You need to find an area of this shape, this heart, very timely because it's Valentine's Day pretty soon. We have a square. I'm going to choose a different color here. 3 by 3, it's 9. We have a circle. Its radius is half of 3, so 1.5. Find the area of the circle. Here's 2 halves of a circle right here and here. Make a whole circle. And then go ahead and just do our radius, or our area equation for a circle. Pi times our radius, 1.5, squared. Add those on up together, 9 plus whatever you get here. That's going to be your area. Simple as that. Last thing you're going to do with these composite figures is estimate areas of irregular shapes. As we all know, most shapes in the world are not regular. They're in fact irregular. Some shapes might look, for example, like a lake. This lake thing right here. If we're going to find the area of this lake-looking thing, I'm going to go ahead and split it into several pieces. I notice that this square is 1 by 1. That has an area of 1, that has an area of 1, that has an area of 1. This looks like it has an area of about a half or so. Roughly a half. I also notice that this shape right here seems to be approximately a triangle. Alright? Triangle that has a height overall of 1 and a base of 2. We could say that the area in that triangle is 1/2 base, which is 2, times height, which is 1. 1/2 times 2 is 2 times 1. 1/2 times 2 is just a 1, times a 1 is a 1. We have another 1 inside here between all these pieces. Last couple of pieces right here, looks like this is another 1/2. We can add these all together. 1 plus 1 plus 1 plus 1 is a 4, plus a couple of halves is a 5. If you want to tack on this extra bit here, this stuff plus this stuff, you can estimate that maybe those together add up to another half. So we'd estimate this area to be about 5.5 or so. There's not going to be an exact estimate, but it's going to be roughly close. Today we went ahead over some composite figures. As always, email me if you have questions. Bring questions to class. You're very welcome to come in after school Tuesday and Thursday as well if you have questions. Yeah, that's about it. Have a wonderful evening. Enjoy. Take care.